In this video we want to look a little bit more at case classes and files. So in previous videos we have read data from files and we used case classes to organize that data. The example of a box score, while potentially interesting example, didn't really take advantage of the full power of the computer. One of the reasons why we do things on computers is because they have the ability to handle large amounts of data easily. For this example, we are going to look at a somewhat larger data file. This data file, which was pulled down from one of a ornl.gov government repository of temperature data for the United States. I used the web interface and I pulled down data for the city of San Antonio, just temperature data. And I did it for, you'll see this starts with 1946 and it goes all the way to 2010, and this is daily weather data. Going back up to the top, there's one line here that has a header. The second line tells us what the values are. This is the day of the month. This is the day of the year, or the Julian day. This is the month. This is a state ID. In this particular file, they're all the same because the only state is Texas. The year, the average temperature for that day, the high temperature for that day, and the low temperature for that day. And so we want to write code that uses a case class to organize this data and then loads it all in using a source, and we can do some interesting things with it. So let's go ahead and create actually let's call this temps.scala, and because we are going to be reading from a file, we'll go ahead and import scala.io.source, and we can declare our case class. We'll call it temp data. So the case class needs to store these various values. The day of the month, which is an int, the day of the year, which is an int, the month, lowercase, which is an int. We'll skip the state ID. We'll keep the year, which is an int. Then going down to the next line, we will also keep the average temperature, which is an int. Actually, we'll go ahead and store it as a double. While in this particular data set, they are always integers. Because we're going to be doing math on them in certain ways, it'll be nice to have them stored as doubles. Tmax is a double, and Tmin is a double. Okay. As we did with the box score, it's nice to define a function. We'll call it parse temps. And this takes a single line from the file in the form of a string, and it gives back a temp data. So we want to split, and as you can see here, these lines have single commas as delimiters. So we can say p equals line dot split on a comma, and then we'll go through dom, day of month, equals p sub 0 dot to int, val day of year equals p sub 1 dot to int, month equals p sub 2 to int, year equals p sub 4 to int, because so 0, 1, 2, 3 is the value we are ignoring, 4 is the year, the average, is p of 5 converted to a double. The max is p of 6 converted to a double. And the min is p of 7 converted to a double. Okay, so that gives us all of the values that we wanted, and now we just have to put them inside of a temp data object. So we make a new temp data object, day of month, day of year, month, year, average, max, min. Okay, so that function will take a single line and give us back a temperature data object. Now we want to open a source to read this file. It's worth using word count to look at just how long this file is. This file has a bit over 23,000 lines inside of it, so that there are no typos. We'll copy that and make our source. Make sure we close the source when we're done. Lines is source.get lines. Temp data is lines mapped onto parse temp, and then we'll convert that to an array so that we have an array of our temperature data. So that's all we needed to read it in. Now, what would we like to calculate from this? Well, some simple things to calculate might be the average temperature for averages for the average high and low over this entire time period. So we'll start with the average. Well, if we want to calculate that, one way to do so would be to take the temp data and map it across the function of underscore dot TAVE, which pulls out all of the average temperatures, sum those all up, and divide by temp data dot length. In addition to the average, we can also get a high and a low by doing the same thing with max and min. It's worth trying to run it at this point. Parse up temp. There's an S on this one, not on the other. This is actually parsing a single temperature, or a single day. So we'll make it singular. And this runs, and here's an interesting problem. For input strings, source, blah, blah, blah. Okay, so we didn't skip the top line. In fact, we need to skip the top 2 lines. We can do that very simply by calling lines.next twice. So let's try that again. We have another exception. What could have caused this one? So we skipped the top 2 lines. This says that there was a number format exception for dot. Well, that's interesting. Where did that dot come from? Well, we could go look at the file again and search for various reasons. Turns out we have to backslash our dot. And you see there's a data point that has dots on it, and then there's some more down in 2008. So basically there's a few in 2006 and a few in 2008. When pulling down this file, it reported that there are dots for data points that places where they didn't have data. So somehow we have to deal with that. And since it turns out those are across all the temperatures, we can just throw those out. So what we're going to do is we are going to filter only things where it does not contain the string of comma dot. And now 23. Oh, I forgot to close off the filter. Now if we run this, there we go. The average temperature in San Antonio is just a little under 70, the average high is a little under 80, and the average low is a little under 60. Now, what other questions could we ask? It's one thing to know what all of the averages are. What about if I wanted to know only the average, but break it up by month? Yeah. So I want to know the average temperature for each month over this entire span. Well, we could write a little for loop that runs through the months, which should range from 1 to 12. And we want to print out the averages. We can actually use the line that we had from above for this, but with one additional caveat, which is that we want this, let's go ahead and put in month here, that we only want this for days that are in that particular month. So once again, we're limiting things, so we will filter things so that underscore dot month is equal to month. We can pretty that up a little bit instead of making the line so long. Run. Okay, so there's clearly something going wrong here. Has anyone spotted it? Yes, we are dividing by all of the data, and so our numbers are about 1/12 of what they should be. How about we make val month data equal to that. Now the reason for doing that is otherwise we would have to do that filter twice. Once before the map, and then another time to find the length. By putting it in a variable, we can get away with doing it only once. And you see that the warmest month in San Antonio is August, followed very closely by July, and that the coldest month is January, followed by December and February, which are, of course, what we would expect from these from this type of data. How about, there's one last thing to do here. How about we count how many days since 1946 San Antonio has had a high of above 100. Highs above 100. And we'll say at or above. So triple digit days. This can be calculated. Well, we can use temp data, and we will use the count higher order method. We could do a filter and call for the length, but all we really want is the count. So we want to count everything where T max is greater than or equal to 100. And we can see that since 1946 there have been 676 days that have been above 100, in San Antonio. So hopefully this gave you some ideas for things that you can do with Scala and how we can use it to process large amounts of information. You can certainly go to this website and download temperature data for your own city and play with it. You can also look at values like precipitation and whatnot. So there's a lot of data there, and you can play with it, and Scala is a tool that you can use for doing interesting things. Kind of run some little experiments, discover things about what the weather is like where you've lived.